Hello, welcome to my channel. In the previous video we have discussed the Kirchhoff's rule, that is junction rule, loop rule, to determine the current in various branch of the circuit and the potential difference across any of the resistance. In that continuation, today we will study about a very well known principle that is given by Wheatstone and famous at Wheatstone's bridge, principle of Wheatstone's bridge. So what is that? Wheatstone bridge principle, it is based on the value of one resistance out of 4, which can be determined quickly and accurately. How? Let's start Wheatstone's bridge. In this principle of Wheatstone's bridge, why this is called bridge and the name of the scientist Wheatstone, 4 resistances are taken. Out of them, one resistance, its value is determined in terms of the other 3 very accurately and quickly. How? Let's see. If the 4 resistances are arranged in the form of a parallelogram or any quadrilateral, you can say like this, and in one diagonal a cell is connected and other diagonal a galvanometer. Galvanometer is the device through which we detect the presence of current in a circuit. So that is connected. This is one diagonal. Here galvanometer is connected with the help of key, and the other diagonal, this is the other diagonal. In between these 2 points, the cell is connected. So if the names are written here for the first resistance P, other resistance Q, then here this is R and this is S, and I write here this junction as A, B, C, D. Then suppose the current moves from the positive terminal of the cell, that current is I. Let I is divided here in the I1 here and I2 here. This I1 is further divided here, suppose it is IG, G for galvanometer, so current in galvanometer, and the rest I1 minus IG is flowing through the resistance Q. Here this is I2, this IG is coming here, so this current becomes I2 plus IG. Now what happens, that at point C, this is I1 minus IG and this is I2 plus IG, so what does it become again? I1 plus I2. And what is I1 plus I2? This is I. So same current I reaches to the negative terminal. So now what is the principle of Wheatstone bridge? According to this principle, if 4 resistances are arranged in the form of parallelogram, that each side represent a resistance, and in one diagonal a galvanometer and other diagonal a cell is connected, then if the resistance, the value of resistances is so adjusted that the ratio of that there is no deflection in the galvanometer, we arrange by taking 4 resistance as the 4 sides to represent the 4 sides of a parallelogram. In one diagonal galvanometer, other diagonal cell is connected, and we arrange the resistance value in such a way that there is no deflection through galvanometer. No deflection means there is no current in this arm, in this diagonal where the galvanometer is attached. Then the bridge, this is the formation of bridge. The bridge is said to be balanced, and in this balanced state the ratio of resistances of two adjacent arms is same as the ratio of resistances of other remaining two adjacent arms. You have to learn this principle and you have to prove also. So in this way, when four resistances are joined to represent four sides of a parallelogram in one diagonal galvanometer, other diagonal cell is connected, and if the value of resistance is so adjusted that there is no deflection through galvanometer, then ratio of resistance of two adjacent arms is same as ratio of resistance of other two adjacent arms. How will you prove? Look, if we apply Kirchhoff's rule here, we have arranged the bridge in this way. So in the loop A, B, D, A, suppose we consider the loop A, B, D, A, then what will you write here? This I1 current is flowing through this resistance P, and in the direction of current we consider the product of I and R minus. So what will you write? I minus I1 into P. P is the resistance. Then in this arm IG, then this again Ig into G, so you will write with minus sign, this Ig into G. Then in this arm against the current you will write with plus sign, so plus I2 into this resistance R, and again this is 0. Loop rule, what was that? The changes in potential difference across any closed loop. All the potential differences, their sum is 0, so you have written as per the loop rule. Now loop rule says this. In the second loop we consider B, C, D, B. So in the B, C, D, B in the loop rule, so in the other loop we consider B, C, D, B and apply the Kirchhoff's second law. So what is this? BC minus I1 minus Ig into this Q. Then in this direction against, so you will write with plus. So what will you write? Plus I2 plus Ig into S, and here against, then you will take plus Ig into G equal to 0. Now in these two equations, since the principle says that in the balanced state there is no deflection in the galvanometer, that is Ig, the value of Ig is 0. So since in the balanced state Ig is 0, balanced state of the bridge, balanced state of the bridge, this Ig equal to 0. So what will you write here? In this Ig equal to 0, so this equation, what this equation will become? This minus I1p plus I2r equal to 0. Then what can you write? That I1p equal to I2r. You can write from the first equation. Similarly, in the second equation, put Ig 0 and this Ig and this Ig 0. Then what will you get? This I2, this I1q equal to I2s. Now divide this equation number 1 by equation number 2. Then what will you get here? This division gives you I1 will be cancelled, So you will get P by Q equal to R by S. And this is the principle you told there, that in the balance state the ratio of resistances of two adjacent arms, that is P by Q, these two arms, is equal to the ratio of resistances of other two arms, that is R by S. You have proved. Now some Viva questions based on it. Number 1, that which two arms are said to be ratio arms, which is known arm, which is unknown arm. So you should learn that here this P by Q is called ratio arms. What does it mean? That you don't know how much is the value of resistance P and how much is the value of resistance Q. Simply you know the ratio P by Q. Suppose this ratio is 2:3, then resistance may be 20 and 30, 200 and 300, or any of the value. So P by Q is called ratio arm. This R is known arm because R is taken as a resistance box in which the known values plus are inserted, known values resistances are there. So this is known arm and this S is unknown. So as the principle says that out of these you can find the unknown resistance in terms of the other three, then what will you say here? That S will be what? Q by P into R. So S is unknown resistance. Now next question, what is the potential difference between the points B and D in the balance state? You know, in the balance state what is the condition? In the principle it is said that there is no deflection in the galvanometer when current is not flowing through it. What does it mean? That potential of this point B and potential of this point D is same. So what is VB minus VD? 0. Or you will say that potential at this point B is same as potential at this point D. So in this way the questions are asked that how will you determine this and what is the potential. Now the third question, in the balance state, if the circuit you have drawn, you have proved, then the positions of galvanometer and battery can be exchanged. That in one diagonal you have connected galvanometer, here you can connect battery and here you can connect galvanometer. So in this way some questions are there. Now sensitivity of the meter, this Wheatstone bridge principle. What do you mean by sensitivity? So if sensitivity is said to be defined, then sensitivity is maximum. The Wheatstone bridge is said to be maximum sensitive when a slight change in resistance creates a large deflection in the galvanometer. It produces large deflection in the galvanometer. This is said that then Wheatstone bridge is said to be most sensitive. A slight change in known resistance or this R produces large change in the deflection, produces large deflection in the galvanometer. Now if it is said that how will you what is the use or the application of Wheatstone's bridge, then how will you say? Suppose one question is asked that what are the advantages of Wheatstone bridge method of measuring resistances over the other methods. This is the one more question asked. Then one thing you know, that in this method we use the null point position or null method. This bridge working or this principle is based on null method. in the null method? First thing is that the internal resistance, due to that the effect on the value of resistance which is to be determined may change. So here, since this principle is based on the null method, so you are determining the value of unknown resistance by null method. So effect of internal resistance such as internal resistance of cell is not there. Second thing, that since it is based on null method, so from null position a slight deflection is easily observed as to measure the deflection directly. And last question, how will you make the bridge most sensitive? How can the bridge is made most sensitive? So if the relative values of all the 4 resistances are of the same order, then the bridge is said to be most sensitive. So I think you must have understood the principle of Wheatstone's bridge sensitivity and why this method is better than the other methods of measuring resistances. Thank you.